Tornadoes. These swirling vortices of wind are a testament to nature's raw power. They inspire awe and fear, captivating us with their destructive beauty. Understanding these meteorological marvels is not just an academic pursuit, it's crucial for safeguarding lives and property. Tornadoes are more than just random acts of chaos. They are the result of a complex interplay of atmospheric conditions, a delicate balance of forces that can unleash devastating consequences. In this exploration, we'll delve into the science behind these whirling wonders, unraveling the mysteries that govern their formation and behavior. From the calm before the storm to the destructive aftermath, we'll journey into the heart of tornado science. By understanding the forces at play, we can better prepare for these events and mitigate their impact on our lives. Join us as we embark on this journey of discovery, shedding light on one of nature's most powerful phenomena. Tornadoes don't simply appear out of thin air. They are the result of a complex interplay of atmospheric forces. They are the offspring of powerful thunderstorms, born from a specific set of atmospheric conditions that must align perfectly. Imagine a clash of titans where warm, moist air collides with cold, dry air, creating a dramatic weather front. This clash creates an unstable atmosphere, ripe for the formation of severe thunderstorms, which are the precursors to tornadoes. As these thunderstorms grow, they can develop into supercells, which are the breeding grounds for tornadoes due to their unique structure. Supercells are characterized by a rotating updraft, a column of rising air that spins like a top, creating a powerful vortex. This rotation is crucial for tornado formation as it sets the stage for the development of a funnel cloud. Within the supercell, warm, moist air is drawn upwards, fueling the storm's intensity and adding to its power. As the air rises, it cools and condenses, releasing even more energy and further powering the storm, making it even more formidable. This upward rush of air creates an area of low pressure at the ground, drawing in more air from the surroundings and feeding the storm. Under the right conditions, the spinning updraft of the supercell can tilt and become more vertical, enhancing its rotation. This tilting motion stretches the rotation, concentrating it into a smaller area and intensifying the spin, making it more powerful. This concentrated rotation is the seed from which a tornado will sprout, eventually touching down and causing potential devastation. At the heart of every tornado lies a mesocyclone, a rotating vortex of air within the parent thunderstorm. Picture a massive, spinning cylinder of air several miles wide, embedded within the storm clouds. This is the mesocyclone, the engine that drives tornado formation. The mesocyclone's rotation is generated by wind shear, a change in wind speed or direction with height. As winds at different altitudes blow at varying speeds or in different directions, they create a rolling motion in the atmosphere. Imagine a giant hand stirring a pot of water. The water doesn't simply move in a circle, it also spirals around the center. Similarly, wind shear creates a spiraling motion in the atmosphere, setting the stage for mesocyclone development. As the updraft of the supercell interacts with the spinning mesocyclone, it stretches and intensifies the rotation. The spinning air is drawn downwards, forming a funnel cloud that descends from the storm base. When this funnel cloud touches the ground, a tornado is born. Tornadoes are as varied as the storms that spawn them. They can range in size from small rope-like vortices to massive wedge-shaped monsters capable of leveling entire towns. Their lifespans are equally diverse, lasting anywhere from a few seconds to over an hour. The speed of a tornado's winds is the primary factor determining its destructive power. Wind speeds in tornadoes can reach over 300 miles per hour, capable of ripping buildings from their foundations and hurling debris with deadly force. The enhanced Fujita scale, or EF scale, is used to categorize tornadoes based on their estimated wind speeds and the damage they inflict. The scale ranges from EF0, with winds up to 85 miles per hour, to EF5, with winds exceeding 200 miles per hour. Tornadoes are most common in the spring and early summer, when the atmosphere is most unstable. However, they can occur at any time of year, whenever the necessary atmospheric conditions are present. Understanding these conditions is key to predicting and preparing for these destructive events. Section 5. Tornado Alley, where twisters run rampant. While tornadoes can occur in many parts of the world, a particular region in the central United States is notorious for its frequent and intense tornado activity. This area is a hotspot for meteorological phenomena that can lead to the formation of these powerful and destructive twisters. This region, known as Tornado Alley, stretches from Texas northwards through Oklahoma, Kansas, Nebraska, and parts of surrounding states. It covers a vast expanse of land where the conditions are just right for tornadoes to thrive. Tornado Alley's unique geography and climate make it a prime location for tornado development. The interplay of various weather systems in this region creates an environment conducive to severe weather. Warm, moist air from the Gulf of Mexico flows northwards, colliding with dry, continental air from the west. This interaction is a key ingredient in the recipe for tornado formation. This clash of air masses creates a volatile atmosphere, ripe for severe thunderstorm development. These thunderstorms can then spawn tornadoes under the right conditions. The flat terrain of the Great Plains allows for unobstructed airflow, further enhancing storm development. This lack of natural barriers means that storms can grow and intensify without hindrance. Additionally, the jet stream, a band of strong winds high in the atmosphere, often dips southwards over Tornado Alley, providing an additional source of wind shear. This wind shear is crucial for the rotation needed to form tornadoes. These factors combine to create a perfect storm, literally, for tornado formation. The unique combination of geography, climate, and atmospheric conditions makes Tornado Alley a breeding ground for these natural disasters. As a result, Tornado Alley experiences a disproportionately high number of tornadoes each year, making it a hotbed for both storm chasers and scientists studying these powerful phenomena. The region's reputation for tornado activity continues to draw attention from around the world. Section 6. Atmospheric ingredients brewing the perfect storm. Tornadoes are not random events, they are the result of a specific set of atmospheric conditions coming together in a precise and often volatile manner. Understanding these ingredients is crucial for predicting tornado outbreaks and issuing timely warnings. Meteorologists spend countless hours analyzing data to identify these patterns. Instability is a key ingredient in the recipe for tornadoes. This refers to the presence of warm, moist air near the ground and cooler, drier air aloft. This unstable configuration creates an environment where air rises rapidly, fueling thunderstorm development. The more unstable the atmosphere, the more vigorous the storm. Wind shear, as mentioned earlier, is another essential ingredient. It provides the spin necessary for mesocyclone formation, the rotating heart of a tornadic thunderstorm. Wind shear is most pronounced when winds at different altitudes blow at significantly different speeds or in different directions. This difference in wind speed and direction creates a horizontal spinning effect. Moisture is the fuel that powers thunderstorms and, by extension, tornadoes. Warm, moist air is like high-octane gasoline for these storms. As this air rises and cools, the moisture condenses, releasing latent heat and further powering the storm's updraft. This process is crucial for the development of strong thunderstorms. These ingredients, instability, wind shear, and moisture, are the hallmarks of a tornado-producing atmosphere. When these factors align in the right proportions, the stage is set for the birth of these destructive vortices. The combination of these elements creates the perfect conditions for tornado formation. Meteorologists use advanced technology to monitor these conditions and provide warnings. Understanding the science behind tornado formation helps in mitigating the risks and preparing for these natural disasters. Knowledge is our best defense against the fury of nature. As we continue to study and learn more about these atmospheric ingredients, our ability to predict and respond to tornadoes will only improve. The more we understand, the better we can protect ourselves and our communities from the devastating impacts of these powerful storms. When these factors align in the right proportions, the stage is set for the birth of these destructive vortices. Stay informed, stay prepared, and respect the power of nature. Moisture is the fuel that powers thunderstorms, and by extension, tornadoes. Warm, moist air is like high-octane gasoline for these storms. As this air rises and cools, the moisture condenses, releasing latent heat and further powering the storm's updraft. These ingredients, instability, wind shear, and moisture, are the hallmarks of a tornado-producing atmosphere. When these factors align in the right proportions, the stage is set for the birth of these destructive vortices.